Good afternoon, NDC. Thanks for coming out for the final session of today. Your brains are probably already melting from all of the cool and fun stuff that you've heard already. Hopefully I can just jam in just one more on top of that. My name's Allison Ravenhall, and I'm a digital accessibility specialist, currently working at CommBank. And I've worked in a bunch of places prior to that, consulting, talking to people about digital accessibility. And today I wanted to talk about apps in particular, because I feel like when it comes to accessibility, a lot of time and space is given to the web. You know, the W3C has published the Web Content Accessibility Guidelines. If you don't know the outline, it's on my shirt. But there's nothing really in the official documentation about mobile. And sometimes project teams take a bit of license with that and sort of go, oh, accessibility doesn't apply to us. And I'm like, I'm here to remind you that it does, because with more and more companies pushing their customers into self-service platforms via their websites and via their apps, more importantly, we need to make sure that these channels work for all of our customers. So I'm going to demonstrate a couple of features of mobile accessibility that you may not be aware of. You may have seen them before. And the first one I want to talk about is screen readers. And for those who aren't aware, a screen reader is a piece of software which basically is an entirely alternate interface for someone who typically is blind or has low vision. And so what the screen reader does is interpret the entire content of a screen and presents it to the user as audio. So you'll move around the screen and you'll be told about all of the buttons, the links, the headings, the images, and everything that's going on and what you can interact with as a user. So we're removing entirely the dependency on the visual interface and replacing it with audio. Now, naturally, I spend a lot of time talking about screen readers. And one of the things I talk a lot about to developers about is labeling things properly for the benefit of a screen reader. So I've got a lot of demos today. I've realized really quite late in the piece that this is possibly a career-limiting talk, because I'm about to name and shame a bunch of large companies for the bad stuff that they do from an accessibility perspective. If your app is up here, I'm not going to apologize. I'm going to charge you for the free audit I've done on your site or on your app. But here we go. We're going to kick off with the Lime app. And Lime is an e-scooter, e-bike hire company. You may have seen the little green vehicles dotted around Melbourne. And they have an app where you can book your scooter, pay for it, and ride. And you might wonder, why is someone who is using a screen reader going to use the Lime app? And I would say, don't be so narrow-minded. Whilst most people using screen readers may be vision impaired, there may be people who struggle with reading, who are using a screen reader as a text-to-speech mechanism. So there's different ways and means, and there's no getting out of doing things properly. So here's the first demo. Listen to how VoiceOver on Apple iPhone announces the first few buttons as we move through the Lime interface.
Lime, bike rider map top bar avatar dar, button, possibly, person. Bike rider map top bar vehicle F, button, possibly, sliders. Bike rider map center user locket, button, possibly, send. Scan, button. Supreme close left grey backer, button, possibly, close.
There's a whole bunch more content on the screen there, but I thought I've made the point. I'm going to hazard a guess. I don't have access to their code base, but I'm going to hazard a guess that those are all file names. VoiceOver, Apple's screen reader, is trying to do a nice job and trying to describe the icons that those buttons are. So the possibly person, possibly sliders, possibly, that's VoiceOver sort of going, I'm trying to help here. That's got nothing to do with how it's been devved. How it's been devved is that first bit, which is rubbish. You know, if you're sort of casting your eyes down and not looking at that screen, how could you possibly know what's going on? So it is in the developer's control to define meaningful labels so that we hear menu button or select vehicle type button or center map on your location button. You know, these sort of meaningful, helpful labels instead. I've got another example here, and you know, so I don't get accused of bias. This is from Android. Android's screen reader is called TalkBack, published by Google, and we're looking at the AFL Live app. So here is TalkBack trying to move through the carousel at the top of the screen. Stream your team in list, double tap to activate, carousel item, augmented reality hub, draft picks, AFL fantasy, Shell fuel offer, carousel item. So the final tile in that carousel is actually some sort of KO streaming sports offer. But for a TalkBack user, all it is a carousel item because for whatever reason, either the developer hasn't filled in the placeholder, it hasn't been provided by the content team. Either way, too bad, so sad. You're not going to know about that offer unless you play a bit of roulette and click on it, just to see what happens, funsies. The other thing that I'd like to point out in this example is the second last offer. It just says Shell fuel offer. From a TalkBack perspective, it just says that. But from the perspective of a sighted user, we're getting a lot more information. We're being told as a sighted user that it's a 4 cents per litre off offer. And that is a demonstration of a screen reader user not receiving equivalent information. You know, 4 cents a litre might be enough to tempt someone to tap in. Maybe not. 10 cents a litre, you've got people's attention. That level of detail, that level of difference may be, you know, what causes someone to engage or not. And by not including that description, you're denying the person the option of even engaging. Now, I don't want to be accused of being relentlessly negative, so I've actually got a good example here, and it's from our friends at Macca's. It is getting a bit late in the afternoon. I don't know if anyone else is a bit nibbly or if you partook in the afternoon tea, but either way, Macca's, nugs, who can argue? The Macca's team have done a really fine job of adding screen reader support in respect to feedback. So when I buy my nugs and I'm selecting a sauce to go with those nuggets, as a screen reader user, not looking at the screen, the feedback that the Macca's app provides tells me exactly what's going on and what happens next. So let's watch the video and let's see if the audio kicks in or if I have to narrate it again.
Chicken McNugget 6PC, $6.55, 1,090 kj. Meals from $10.90, 2,330 kj. My Macca's. Close. Button. Double tap to activate. Barbecue sauce. Double tap to activate. Button. Barbecue sauce selected. Add to bag. Button. Double tap to activate. Add to bag. Selected. Item added to your bag. Bag available near the bottom of the screen to check out now.
So that piece of feedback right at the end there, that was a deliberate decision made by the Macca's team. That was a deliberate method call to provide that piece of feedback corresponding to the visual animation that you see of that nuggets box falling into the bag. It's a really well-crafted experience from a screen reader's perspective because you've been given the status report. the item selection has happened, it's been successful. But what really sort of tips it over as an awesome example is the fact that they're telling you what comes next. The order is available at the bottom of the screen to check out now, and the visual design is such that because the checkout now button runs from edge to edge, it means that someone who is using a screen reader and cannot see the screen, they're running their fingers down the screen, and the screen reader will just detect the fingertip location and just announce everything as you pass through. It's just like announce, announce, announce. And it'll just be going chicken McNuggets, chicken McNuggets, chicken McNuggets, all the way down. Because that button is edge to edge, you can't help but encounter it as you run your fingers down towards the bottom of the screen. So someone is going to, meet this button, and they're going to hear checkout now, and they're going to be, on their way to getting their nugs, which is really super nice. I rave about this example because I don't see it enough. So it excites me. Back to stuff that doesn't excite me. This is flying the friendly skies with Qantas, our Australian airline. And I was just talking about one of the ways that screen reader users navigate by touching the screen and just hearing the announcements as they explore. One of the other ways that people can navigate is via element type, and it's really, really efficient if it's done well. In this case, I would like to be able to navigate by headings because there are very clearly delineated sections on the screen, large bold text, and a lot of buttons and interactions in between. If I'm moving through this screen linearly, and you're only seeing about a third of the full page here, it's going to take me a long time to get from top to bottom. But if I could scan by headings, which you would probably do as a sighted user, then your navigation experience is going to be super, super efficient. However, it does depend on the code. Screen readers can't detect big bold text equals heading. They need to be told in code, it needs to be defined. And if it's not defined, then you get an experience like this. Hello, Allison M. Plain button. Points, 137,000. Status, 0 button. I'm sad. And then I'm swiping sideways with 3 fingers to change scan mode. Controls, headings, swipe up or swipe down to read by headings. No next heading, no next heading. So unfortunately, Qantas hasn't built in the ability for screen readers to recognize and identify and use those headings to navigate. That efficiency is lost, and I'm a bit sad. While I'm on the topic of Android screen readers, there are multiple Android screen readers available to use. If you are going to pick up a screen reader for Android use, I would recommend that you pick up Google Talkback. All of the screen reader user surveys point to this one as being the most popular, and from my testing, it's also the most robust. So if you're on another device which ships with another screen reader, maybe pop into the Play Store and get yourself Talkback instead. So just wrapping up with screen readers, the most important thing you can do is label your things. Label your things, make it clear what's going on. Once your labels are sorted, you can think about how you're grouping things. If you're writing apps that use a lot of tiles or panels or cards where you've got multiple views inside them, you might have 5 views with 5 different little pieces of text, but they all relate to the one entity. As a screen reader, the default behavior is to drill down to the lowest level and announce all of those views independently. It's a really inefficient way to fly. So as a developer, it's in your power to define groups of entities such that a screen reader moves through one card at a time and hears the whole announcement. And the extra context and the extra efficiency that you get, win-win. Roles and types and traits are super important as well. I need to know that something is a button in order to think, I'm going to activate that. I'm going to interact with it. I need to know that a text box is a text box. Simple as that. If you're building custom components, you also need to be aware of telling people about the component's state or value. And finally, if you've got all of those basics sorted, you can think about feedback. So feedback might be a custom method call like we saw in the Macca's app. It might be managed by setting focus. It might be, I'm not sure what else it might be, but either way, your screen reader users are depending on you as developers to keep them informed. Even something as simple as a loading spinner can be very confusing if you don't bother to either set focus to it or announce that it's happening. People are left wondering because they don't have that visual context, is my submission happening? And then they might try and do it again, and then you get stuck in a bit of a nasty loop. So screen readers take up a lot of my job. It's just taken up a fair chunk of my talk. But I'd like to move on because accessibility is about way more than screen readers. And one of the other things that I talk about a lot with my devs is big text. So this is moving down the vision spectrum a little bit. It's moving on from folks who are not using any visual prompts to people who are using their vision, but they need a bit of assistance in terms of making stuff big in order to make it work for them. So there's a couple of features, there's a couple of ways that are built into your phone already that makes stuff big. You can go and have an explore and a play with these. On Android, we have magnification, and just like it says on the box, magnification applies an overlay over the top of your app with basically a magnifying glass effect, like this. Come on, there we go. And this one is not audio because we're off the screen readers now. So from a developer perspective, you can't really do much about this. This is an overlay which is applied on top of your app experience. I'd also like to point out that that level of magnification is the lowest level that the magnification feature supports. If someone needs it, they can make stuff a lot bigger in that box. So it's a really nifty feature. Just to be confusing, iOS has the same feature, but they call it something else. It's called Zoom on the iOS side. And both Zoom for iOS and magnification for Android both have two modes. You've just seen the magnification sort of as a magnifying glass where it's partial page. This quick demo is the whole page, so the whole page gets magnified, which might be a little bit more usable, but you know, choice is good. Somehow I've come back to Macca's again. I must have been on a bit of a theme when I was getting these examples together. But again, I think it's worth pointing out that this is the lowest level of magnification that Zoom supports, which is about half the width of the screen. And this is captured on an iPhone 12 Pro. You can scroll up to the point where that account button would take up pretty much the entire screen. So, you know, it can get super, super chunky. Now, as developers, like I said, you don't have much control over this thing. It's an overlay interface on top of your app experience. But I would ask you to take back to your designers the thought that if someone is seeing your app, you know, potentially through a porthole like this, the location and layout of your elements becomes really, really super important. If you've got too much white space between your things, you're making them very hard to find. If you've got a lot of top aligned stuff and then a sticky footer, and a lot of space in between, you might have someone searching around for a significant amount of time before they find that bottom thing at the bottom right at the end. But this is a developer conference, and I do want to talk to you about things that you do have control over. And one of the things that devs have a lot of control over in the app world is font and text size. So font and text size, they behave slightly differently from Apple and Android. And even within the platforms, Android is inconsistent in the way that it scales up text, just to be helpful. If you want to push your Android app to the max with respect to text size, see if you can get your hands on a Samsung Galaxy, because the text size on those devices goes up to 200%, as opposed to a Google Pixel, which only gets to 130. If you're really gonna push it, get the Galaxy. And if you have designed and built your app well for the large text experience, you'll end up with something like this from PTV. So Public Transport Victoria publishes an app which enables us locals to plan our trips around Melbourne and Victoria via bus, train and tram. And this is the journey details page shown at the default text size for an iPhone, and then the absolute largest text size. And when I say the largest text size, this is the largest accessibility text size. If you go into the regular display text size settings, you can chunk it up a reasonable amount, but if you go into the accessibility settings, lo and behold, there's another 5 levels of text size that you can go extra large. And what I'd like to point out in this, and the shout out for PTV, these guys have done an awesome job because they've recognized the fact that in the default text experience, there's a lot of white space in this first column. If we just resized this layout as it stands, there would be a lot of wasted white space. And the final column, which has got all of the detail in it, would be super long. It'd be chunked. It'd probably be about half the width, which would make the content heaps longer and really hard to read, and probably a lot of wrapping as well. But what they've done is they haven't lost the information, they've just moved it. So all of the arrival, departure, start times have been wrapped into the details column. So this was a deliberate decision. That doesn't just happen by accident. It's really quite nice. The other change that they've deliberately made when they've transitioned from default text to accessibility text sizes is that the single line for each journey destination, it's a single line and it's truncated. Over in the biggest text size, that limit has been removed and the destination line is allowed to wrap as long as it needs to. So we're not missing out on any information. You could actually argue that that one is more informative because there is no truncation, whereas there is in the default view. Just to be balanced, I gotta show you something shit. So here is Flybuys. It's one of our local rewards programs for shopping at certain retailers and grocers. And you can tell potentially that if you compare the pair, default text size, biggest text size, too bad if you actually need biggest text size because nothing's changed. So dynamic type hasn't been supported, nothing's moved. Oh, one word's gotten bigger, but the panel around it hasn't. Too bad, so sad, no Flybuys for you. And just to be fair, because there's 2 major retailer programs, I thought I'd better check out Everyday Rewards as well, and they're just as shit. So, no, they're actually more shit because there is absolutely no change between the default and the largest text experience. So, yeah, if you're low vision and you rely on large text to read your phone, read your offers and stuff like that, I hope you don't want to participate in Everyday Rewards. I mean, obviously, hopefully there's a web experience that might be more accessible. But, fingers crossed. And why should we be pushing our users around to, have to try alternate experiences? If they're on their phone, the thing that's on their phone should work. Well, you'd like to think. Anyway, big text checks. If you're building an app and you want to make it work for big text, the first thing you have to do, the thing you have to prioritize absolutely out of the box, is dynamic type. Make sure that you've got that PTV experience where all of that text gets chunky. It's going to look foreign. It's going to look weird. You're going to go, the first time you see it. But the thing is, for the most part, it's not built for you. That large text experience probably isn't for you. It's not built to suit your need. So, think about the need of the people that you're serving. They're going to be more concerned about the completeness of the information that they're receiving than potentially, the niceties of the layout that you spent so long crafting. And this is a message that you might have to take back to your designers, because your designers are really going to, see their baby being distorted and stretched, and they're going to, have visceral reactions. I've seen it. Once your dynamic type is working and your app is actually responding to the user settings and things are getting big, you may have inadvertently caused some issues with respect to truncating. So we saw the truncating issue in PTV. They'd capped that line length or that number of lines to 1. You might need to revise your limits on lines. You might also have to look at overlapping issues, particularly if you've got a 2-column layout and you've got, well, I work at a bank, so the thing I always see is a transaction description alongside a value. If the text gets big, bang, they run into each other. They either overlap or truncate or something. And you don't want to truncate like transactions, transaction values. People want to know exactly how much they spent. You don't want to be cutting off values from either the front or the back end of a monetary value. Once you've got the tweaks ironed out, then you can look at the next sort of level with respect to big text, and you can think about making your layout responsive. Do a PTV, assess the layout in that big text mode, and really think about, are we making the best use of our white space? Are we making the best use, can we rearrange this information to make it more readable? Do we need to shift from a multi-column layout to a stacked layout to accommodate this big text? Now, the final interface I do want to talk about today is speech. And I want to point out that speech interfaces are not smart assistants. I am not talking about Siri or Alexa or OK Google or Cortana or any of those things. I'm not talking about setting an alarm, playing music, looking up trivia, and all those sorts of things. I'm talking about an entire interface for driving your device, your iPhone or your tablet, your mobile phone or your tablet. My bias is showing, sorry. So the speech interface on iPhone is called voice control. The speech interface on Android is called voice access. And they behave in a very similar fashion in that they provide a visual overlay on top of your app experience, tagging all of the elements that it deems interactive. And then you can activate an element by name or by tag number. So I've got a quick demo here. This is going to be me talking to my phone. It starts quiet, then I turn on voice control and I start talking to it. So you're just going to see some of the typical interactions that you would have on a phone, scrolling, swiping, selecting things, changing apps, and all that. And then we'll talk about it. Oh, she's not talking. So I've said show numbers, and it's showing the number tags. I've said show names, and it shows the name tags. Open app switcher. Show grid. Tap 10. Scroll to bottom. Oh, I'm getting ahead, sorry. Tap view all. Scroll up. Oh, swipe up even. So both scroll and swipe are supported. Now I'm scrolling right, and it is moving the carousel at the bottom of the screen. Tap find your movie. Tap cinema. Swipe up. Scroll up even. Tap Jam Factory. Tap Morbius. Three, 4, 4, 6, and then we're off into the browser, and voice control follows me into the browser. Voice control follows you everywhere. It's a little bit creepy. Voice control and voice access recognize web content. It will tag on web stuff as well. This is an app talk, so I'm going to focus on the app side. You'll be happy to know I did not proceed with my booking. I did not go and see Morbius. I still haven't, and I'm happy with that decision. So you can appreciate that was just a really quick glimpse at what, like, you didn't miss anything by the recording not happening there. I literally was just saying those things, and some of you might have been able to see the caption that was appearing at the top of the screen. Those are the matches that it's recording against my voice. So I was saying exactly what I did when I recorded this video. So I activated things by name, I activated things by number tag. I also used the grid to, send a touch event at a certain location on the screen. There's a lot of commands to do with dictating and editing text, as you might imagine. Doing all of that by voice is tricky. So